Okay, just waiting to make sure we're all up. It looks like the stream is up. Everything is going good. Can get started. It's been a while since I streamed last. Been a busy month or so. So today, just kind of recap where I am in the debugger. Let's just run it here. VDB. Yes. So last I was running VDB on the test bin. It would run and then it parses all the debug info, or the debug info that I'm interested in right now. But then it hits this process not found, but then the process runs. So I was really confused by that. So off stream, I was playing around with it and I did figure out what was going wrong, which is if I go trace VDB, and I'm really curious about, I was stracing, so the tracing the ptrace get registers, or any ptrace call rather. So you can see here, ptrace get registers, it gets that ID of the child. So this is the call, right? Tell me what's called. Ptrace get regis is the constant of what we're, the actual ptrace call we're making. Then we pass in the child ID and we set in a empty struct that gives us the list of registers. It's all good except that the next ptrace call, ptrace continue, for some reason my child ID has been set to 0, and then I get an error search. Meaning there's no such process. It can't find that process. That's the problem. So there's some kind of undefined behavior happening in my ptrace module. So we got to figure out what's going on, what I messed up. And that is kind of where I'm at right now. So let's begin by looking at, let's look at main. Yeah. And if we run into the run debugger, we see we call tracer init, and then tracer wait, tracer read registers. This is the ptrace call that we have, that we see here. And then we see ptrace here. So this, between these two calls, I'm having some bad behavior occur. And that bad behavior is taking self.pid and setting it to 0. Hey, VMPol, how are you doing? Oh. So I've got to figure out where the undefined behavior is happening. And I did see this in was I using GDB to debug this? Yeah. Once I figured out that there was something going fishy there, I found out in GDB that for some reason this ptrace call is unsetting my PID value. So I need to figure out why that is. Yeah, I'm doing well, thank you. I'm glad you're still alive. I'm still alive as well. like I was saying a little bit earlier, I mean, just when I started the stream just a few minutes ago, it's been a busy month, so I haven't actually gotten much work done on since the last stream. I think where I was at last stream, it was dealing with the uh, dealing with this ESRCH error, the error search, the process not found. And off stream, all I found out was that it is there's some kind of undefined behavior that is resetting my child ID from the actual child ID to ptrace or to 0, which is not ideal. Something I could do is Zig build dash was it, I think it's D LLVM. Yeah. And then I can do VDB. I will do this in GDB. Okay, and oh, it doesn't like that I passed arg, so it's the args. What is it? Info args. How do I see GDB pass arguments to program? Pass arguments, you can use dash args option when starting GDB. Okay. Followed by the program name or its arguments. And its arguments. Okay, so if I do it like this, TUI GDB. Oh no. Args. Okay, there we go. And then I like layout registers like that. Yes. Though actually, I think I was using DD. DD? Oh, DD, not DD. OS software. What's it called? GF. I believe that's it. GF2. GF2. There we are. Then if I do, let's see, commands. Exe. Here's the path to executable is zig out slash bin slash vdb and zig out slash bin slash test bin run. Can you get the working directory? Don't ask. Yeah. So then I need to go to watch files. Source, let's do main. Need to set a break on 69. Oh, this is why. Yes, let's see, exe, let's run it. gf2 dash args, and we want it to be vdb sig out bin vdb sig out bin test bin. Okay, we want to break on main. See source. Yeah. So hit next. Watch is here. I'm gonna watch trace. What I'm gonna do is I'm gonna just stop this. This is not working the way I want it to. This is why I'm working on my own debugger. Let's make sure I haven't worked anything. Okay, now let's focus on this real quick. Hide your chat, sorry. I think it's yeah, right here. Yeah. Okay, there you go. Just gotta wait for it to get there. It's pretty slow. She'll get there. Here we are. So if we look at the trace, we could see PID here. So I'd like to see when that gets see GDB set watch point on variable. So if I watch trace dot PID, does that work? Okay. And if I do continue, I say info frame. Definitely, okay. Definitely in the read registers call, somewhere here in ptrace. It is. This is being changed. I was kind of hoping it would break exactly in the code where it happened, but I guess that's not the case. Ooh. Okay, well, all I could think of is we have this int pointer, and it's taking self pointer to self registers. And I wonder if this is not correct. And that is messing up, because that's the only thing that would make sense. Is that this pointer is not as big as expected, and then the PID is getting written over. So I guess we should take, let's see, print address of self. A trace. So 7FCBA8 print self dot PID trace.pid CC78. Okay, so it's some multiple of 16 bytes beyond that, or yeah, guessing then self print trace dot registers CBD0. Okay. Yeah. It'd be nice to see what the layout here is. CBA8. Okay, so this breakpoint is the first thing. In here. In fact, let's just ref trace ref trace dot breakpoints. Yeah, so there's that. And breakpoints is a struct, a hash map. Size to breakpoint, okay. CBC0. CC7C. CBD0, CBC0, CBD0. So that's okay. So registers is after allocator, but before trace stats, trace state, trace state, and ID 7, 8. Okay, so yeah, 10, 11, 12. 9ABC. So yeah, 4 bytes. That makes sense. So the question is, I wonder if I made this, because this doesn't do anything. So it did first. That'll change. The second. Okay. Take a look at trace. PID is now set to 0, and Tracy state is now set to stopped. So yeah, it's just overwriting a whole bunch of memory. Some what we call undefined behavior happening here. And that is because this must not be correct. Must be missing registers that are expected to be written to. Okay, so now the question is, what registers are expected to be written to? Let's look at ptrace real quick and do get registers. So copy Tracy's general purpose or floating point registers respectively to the address data on the tracer. See sys user H for information on the format of this data. Address is ignored. Note that Spark systems have the meaning of data and address reversed. That is, data is ignored and the registers are copied into the address. Ptrace get registers. Ptrace get FP registers are not present in all architecture. And then you have this get reg set. Read the Tracy's registers. Address specifies in an architecture dependent way the type of registers to be read. Int PR status. So note PR status with numerical value 1 usually results in reading of general purpose registers. If the CPU here, for example, if the CPU has, for example, floating point and or vector registers, they can be retrieved by setting adder to the corresponding int foo constant. Data points to a struct IOVEC, which describes the destination buffer's location and size. On return, the kernel modifies IOVEC length to indicate the actual number of bytes returned. So this is where I get to issues here. See, that's the was it user? No. UAPI. Yeah. x86. Ptrace. Okay, so we want Arch. We want x86-64. Do they not have a specific one? Arch x86 include Here, x86-64 define here. Okay. API. So I'm looking at the Linux UAPI. I want ptrace. Oh, ptrace. It's just the general one that sets, yeah. Ptrace syscall info reg set. UAPI ptrace. Let's take a look. Aha, see, this is okay. This is where I got the registers from. Struct ptregs. CABI says these registers are called preserved. They aren't saved on kernel entry unless this call needs a complete. It's our call clobbered, always saved on kernel entry. It's this call entry, this, yeah, here's all these. So did I unsigned long? Here. Maybe I missed something here. $11. Okay. Oops, yeah. No, so I've copied everything over, same flag, same everything. So that's all right. S is in twice. Ooh, wait a second. SS. Okay. And CS. Where? So this isn't correct. What is? Because obviously this x86, something's wrong. Not, it's overwriting a whole bunch of data. Hmm. Okay. Let's try, maybe we need to try using this get reg set. Let's do it. IOVEC. Base multi-item pointer, view8s. Length size. Okay. Equals standard.posix. The IOVEC. And what we're going to do is at, see, pointer cast. Self.registers. And the length, so it should be pointer, right? Base. And we should have length equals, right? Length, yep. See, size of x So then trace these registers. Address specifies in architecture dependent way the type of registers read, NTPR status, numerical value of 1. So you gotta do ptrace get reg set PID, and then this would be address is 1 int from pointer. I don't think we need int from pointer. I think we just need data points to a struct iovec. I believe, yeah, it's an external struct. Okay. Did I mess up the register set? Okay. Let's take a look at this. Take a look. Wait. Oh, I gotta rebuild it with LLVM. Zig build dash F dash D LLVM. Wait for it. Zig. Right. All right. Failed to stop the child, which is fair. I think that, okay, so it got beyond this. 168 bytes. I want to see how, I want to see 168. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. All U64s. $68. Okay. I do still want to see I want to see this. Okay. Okay, so it did read just 168 bytes. Okay, so I guess that is. I don't know what was going on previously. Why I just wrote past the thing. It must be reading. I don't know, but we will deal with that then. Okay, well that's fine. Let's see. Let's take a look at the changes here. A split. Yeah, I want to split in W. JJ select, see, split, delete. What's the key binds? Like, oh, there it is. Confirm changes. There you go. Let's see, fix UB with reading registers. And this, I'm still unsure why get reg didn't read past the end, read too much. It is hard to find good information about what's the structure of the registers. Looks like for this call. However, using the newer API get reg set seems to work with the structure in UAPI slash POSIX. POSIX H4 x86 4. Okay. All right. So go back to main. And it is saying that the Tracy wait isn't working right. And that is because setting the breakpoints doesn't actually work. So let's work on that. First, okay, I'm gonna be back and take a little break real quick. Okay. That break was not as long as I thought it would need to be, but that is fine. Okay, so for now we're good here. We need to start working on setting our breakpoints, which means we need to be able to get line addresses, which this function actually doesn't do anything right now. Aha, but every compile unit has a line matrix. So define, so get line address, and we give it, here we're giving it bins test bin.zig. The file line number. We need to get that. First, we find the right compile unit for this line number. Do const file equals, we're going to do path dir equals standard.fs, is that what it is? Dot path dot base name. That would be path. This actually gets us to file. And see standard dot fs dot path dot dir name. Okay. It's unused constant. It doesn't like that. So now for cu rc li dot bug info has compile units. So we just gotta go through yeah, fix this at some point, but it's compile units. Compile units is an array list of compile units. if header line header file metadata. If DIRs, so yeah, we gotta go through DIRs and then through file metadata. So if dir, see, how about unit 4 CU C. CU dot, yeah, DIRs. If B equals dir, or standard dot mem dot equal U8 then if not standard edit, then we're going to continue. Else for let's see, for cu dot files. Let's see, file data. F. If standard, see, if not standard dot mem dot equal U8 F dot name, then continue. And then if so, we do compile unit. Otherwise, CU const CU equals null, and this is var target compile unit. And we'll say target compile unit equals CU and break. We're actually got a break, not just this loop, but we're going to say this one. So we do this, call it CU search. CU search. Okay. And path is used, so that's not needed anymore. And so is LI, right? No. Okay. Oh, see, it's a compile unit. Optional compile unit. Expected const U8 found optional const U8. Dir. Path is a file in the current directory. No directory component then returns null. Let's try that. Okay. To do. Oh my goodness. I'm not typing it today. Okay, to do. Verify that the empty string is the right thing to put here. Add some more context for stuff. It may be that I need to put in the absolute path. I'm not quite sure how DWARF handles that. I think the paths are absolute. In which case, maybe a single is correct. Okay. Yeah. So now we got the compile unit. So now we gotta get the line info. Line mat equals info cc target cu dot see if target cu is null. Return there we go. And then line mat equals const line mat equals dot line matrix. So then we need to find where the file equals the file number. The line number equals the line number. So so we need to keep track of the index, so the ID of the slide file number. Two. FN init. All right. Files. Allocating metadata for files. And then we're iterating over every file. Let's go back up to the file section here. So directory entry format. First entry in the current directory. First entry is the current directory of the compilation. Each additional path entry is either a full path name or relative to the current directory of the compilation. The line number program. Okay. File name, entry format, count. A count of the number of file entry format entries that occur in the following file name entry format field. If this field is 0, then the file name count field must also be 0. File name entry format. A sequence of file entry format descriptions. Each description consists of a pair of content type code and a form code. Count of the number of file name entries that occur. File names, a sequence of file names, and optional related information. Each entry is encoded as described in the file name entry format field. Entries in the sequence describe files that contribute to the line number information. First entry in the sequence is the primary source file whose name exactly matches that given in the DWARF attribute name attribute in the compilation unit debugging information entry. Line number program references file numbers in this sequence beginning with 0 and uses those numbers instead of file names. Okay. So actually, I don't need to keep track of the IDs because it's just whatever, it's their order in sequence. So we can just undo all of this. Yeah. What's wrong here? It doesn't like, oh yes, so now I have to find the index of the file name in the list of files in the compile unit. So let's actually, since we're already here doing that, var target file index. Let's do f file index, yeah. We're going to call this a with u32 set equal to 0, set equal to null, and target compile unit. Then we do file index, and what we're going to do is I. Okay. And now we know where the file is. Truncate. And okay, so now what we could do is go through the line matrix and find where the file is right and the line is right. And then we can get that addresses because we want the list of addresses. Okay. Oops. Certainly better ways probably to do this, but we're gonna do it this way first. Then we're gonna figure out what's a better way. Okay, so for file, for line, actually state in multi-array list. Okay. So what we really need to do is slice, say states equals const states equals line matrix dot data dot slice. State dot if state dot file equals file index and state dot line equals line. So then we're going to add it to our addresses. So let's see, we need to create an array list. We're going to return. Let's take a GPA. Yes, it does. GPA, no, is equals what is it called? It's standard dot array list. That's what I want. Of address. U64s. Dot empty. Okay, and so if all these are equal, then addresses dot We did the error defer. Addresses. .init. Unit. GPA. Append GPA, and we want to append state dot address. I believe that's what it is. Address. Member function expected one argument found 0. Oh, no, I want need access multiple fields. Calling this may be more efficient than calling items multiple times. Which slice is this array, a multi-array list slice contains cache start pointers for each field in the list. These pointers are not normally stored to reduce the size of list memory. If you're accessing multiple, then this field, then get the field arrays from the slice. So if we want to do items, so you do like state slice, and we do files equals states dot items dot files, and const lines equals states dot items line, and const adders equals states dot items. Yes. Okay, and then what we need to do is for states, for files, lines, and adders, you get FLA, F equals file index, and L equals line number, then append A. There we go. Okay. Pair union is ignored. Try out error out of memory. Okay. Catch. Addresses to own slice. Okay, let's see if this works. Failed to stop child. Okay. So we get the register set, we continue. Child exited. Yep. So we failed to stop the child still. Okay. Let's take a look at main here. Get line addresses. And here we set the breakpoint. Yeah. So let's test this out. Here we go. Let's wait for the to clear out. All right. Oof. That doesn't look right. Oh, there you go. Okay. So we get a bunch of undefined data. And the address size is 0. Okay, so we need to jump in here. And to do that, we need to build it with LLVM. So waiting. Yeah. Okay. It doesn't go in. Why does it not? Come on. I want to step inside here. No compiled code for. You kidding me? No compiled code? Let's try it with GDB just straight. 2E. Dig out. Then dig out. Test. Dig out. Bin. Test bin. And I want to break on break search/dwarf/debug info.zig and line 195. No compiled code for 195. Really? How about break source/dwarf debug info.zig function not defined. Really? Let's see, start. Next. We enable. Okay. L. There we go. No source available. Okay. Okay, so this is the pane. This is pane here. Let's just do some log debugging. Log.debug. You want to log path line. Okay, and then searching for through compile unit number. Okay, and endures. Files. Files. Okay. Let's see what we get here. Mm. Yeah, okay, so a bunch of undefined data. That is what we call not bueno. So the data is becoming undefined. Readers V5. Do this, but I want to output this out to out.txt. Compile. Okay. DIRs. So here's the DIRs. DIRs there. Debug info. Compile unit. See, compile unit does have a format function, so we should just print every compile unit as it's been formatted. Problem is that Yeah. Searching through CU2 header, bloop, you type file. So it has all the information, but the directory names and the file names are being borked as undefined. Means I must be kind of ironic. It has lengths of undefined data. But what could it mean? Let's see, I think it's debug info and read file unit. Info from compile unit. If you were appending to the compile units, the directories and files. Okay, so let's take a look. Directories here is a bunch of undefined data. That might be my problem. Let's see. And files is, yep, another one like that. The unit version, DWARF version 5. Meaning directory formats. We get the formats. Yeah, we read U32 number of directories. We allocate that number of directories. Allocating a big pointer. Why don't I just use an array list here? Like, yes, I know how many there, so I can allocate. But why not? This is some old code. How old? I don't know. J annotate. You know, a few months ago, apparently. So maybe not as old as I thought it was. Pointer size. Here we're just getting the names from the directories. There's 4 formats. So if it's a string, dir pointer equals take delimiter inclusive. Where's R coming from? R is the reader. There's a bunch of pointers into string memory. Here's a line string pointer. Uh-oh. Build LLVM here real quick. Info from elf. Let's read from elf, debug info. Setting it to the compile unit. Yeah, here. And then it's going to return debug info sections info. Don't really need. So this compile unit comes from here. Somewhere that compile unit is being unset. Or no, all the things that it points to is being unset. after the line number program runs, we get the debug info for all the files. Okay. So it exists after that. But between then and then, okay. So between bug info between here and here we are. There it is. We're freeing all these sections, and we don't want to do that. We want to error defer these, I think. The line address for test bins Zig 3. Bins, test bin Zig 3. So it should stop right there. Why is it not? Why does oh? That's why. Okay, still should be bins. So the DIRS is absolute. So I need to check. Okay. The files here are relative to this directory. Relative to some of these directories. So what we need to do is this. Let's see if we can get this real quick, because I gotta finish up here soon, go lunch. Go to get line addresses. Instead of looping over every file, what we want is, yeah. Oh, yeah, F. So what we want to do is if we're going to check the dir, which is abs dir equals f dot dir or else. If f dot dir equals null, to do, we need to handle version 4, where the dir might be null. Okay, and then so if it's null, continue. And what we need to do is get the absolute directory from the path name. So const dir let's see what's the absolute path. Path there's a non-absolute path from to to. So maybe it's in standard IO dir curder. It's a dir and then real path means the canonicalized absolute path name of subpath relative to this dir. If subpath is absolute, ignores this. Out buffer. Real path alloc. I think we got real path file. This is just a mistake in the docs. Okay, real path file alloc. That's what I want. Defer dir dot d free GPA dot free dir. What we're gonna do is standard dot io dot cwd dir dot cwd dot absolute path real path file alloc io subpath is what we need to do is none of this keep path a GPA. I have to pass an IO to here. Ugh, IO. Okay. And then what we need to do is in here, now that dir is an absolute dir path, what we need to do is generate actually you could probably just check instead of right, isn't there like a subpath is sub relative fs path, standard fs path returns the non-absolute path. Ugh. I ought to do is okay. So this is frustrating. Just to kind of go over what I'm thinking of here. Compile units have this header, and they have some directories. Every compile unit has a directory, and every compile unit has files. And the way that the debugging format separates those out, it has the directories and the files. But as can be seen in here, these directories aren't like, they're just like parent directories. And then some of these files belong to some of those directories. Some of these files are subdirectories. Better examples right here. os/linux/tls.zig. That's in the file name. And it's just saying, oh, everything's under libstandard. But then you can have io/writer.zig instead of canonicalizing these to be, here's all the directories and then the file names, and you can say, okay, this file belongs to that directory. They've split them up. Why? It makes no sense. Like, there's no hierarchy. File systems are already a hierarchy, so why split it this way? So what I need to do is go back, and the way we parse compile units, I'm gonna have to go fix it. And I think what I'm gonna do is intern all these strings. Before I wasn't interning the strings because I didn't want to do a lot of copying, but I'm going to just intern these strings, which means I can then drop all this string table again, because all I'm doing is just intern all the string data into my own structure where the directories and files are like put together. So then when I get it, it's like, oh, we don't want to copy all this data over and over and over again. But I think I'd rather just copy all that data. I don't know. I gotta think about it. Gotta think about a great way to do this, because right now what's happening is like, I have no clue. I have a file path that's relative to wherever I am running my debugger, and I've got to parse out that file and make sure that but I don't know where the compile unit decides that is the top level file. And anyway, okay, I have to close for today. Thanks for watching, everyone. Sorry if In's a little frustrated, but I will see you later.